That's fine. I'll be starting now. So today's our discussion is NumPy. So what do you mean by NumPy? Like
NumPy is a module used for calculations.
exactly. It makes calculations much faster. Like basically we use NumPy just because it uses less storage and it is compatible. Like however we want, we can customize it. Basically, a size of integer is 4 bytes, right? So like it might take more space in our traditional process in Python, but by using NumPy we can reduce that by half or even more. So that's the reason we use NumPy. So that's not only a single use case, there are a lot many use cases. Like it is also easy to learn and it is used for vector databases. I mean, you can use it for matrix multiplications, and there are many more applications using NumPy, and we'll be discussing that step by step. And yeah, let me start. So before getting started, like we can run NumPy anywhere, but the traditional, like the normal approach which is used to run NumPy is on Google Colab. One second. Am I sharing my screen right? Yes, right. Actually, we can use both like Google Colab or Jupyter Notebook. I'll use Jupyter Notebook for now. So for setting up, let me open this folder. I'll create a subfolder in that, a new, and I'll name it NumPy. So you need to open this in a command prompt. Where is it? Open in terminal. So first we need to we need to set up a virtual environment. Even if it is not set, it's fine. But it's fine. I'll directly continue. Pip install NumPy. The first prerequisite. We don't need virtual environment because we'll be working it online. Like we'll get a URL and we'll be working on that directly. So first one, we need to install NumPy and then we need to install Jupyter. Basically data analytics or anyone, like if they want to get any visualizations, most of them use Jupyter Notebook only, Jupyter Notebook or Google Colab, anything. But for now I'm using Jupyter Notebook as it is simple to install also. Next, pip in, install Jupyter. So it takes some time to get installed because it's somewhat heavy because it supports over 40 plus languages, so that's the reason it takes some time to install, and it also has some space. I'll check, like I'll demonstrate by creating a file there, and it will get directly get reflected back into our own folder. I'll show them. I'll show both of them. So I try to do it parallelly. I'll also give the commands after the class. You can import any library. If it shows the library is not existing, you can directly install it in like install the library and use it. But I think it supports most of them without even installing. Let's check it when we go deeper into Jupyter Notebook. So after completion, you need to enter a command called Jupyter Notebook. So it will directly get open into Chrome or any browser, which is the default. Basically, we can use the normal ones also, but NumPy, which is a library, it gives more options. Like it's more flexible when we are working with arrays, or when we are working with matrices. It's more flexible because it has some functions. Like someone has designed a package, right? They designed a package in a way that it is very simpler for everyone to understand and use, so we can directly use it without any complexity. We like it is very fast, it is very quicker than anyone. We use sort, right? Sort methods normally. Here we'll use NumPy sort methods and everything. I'll show it one by one. It's taking longer time than expected. So did anyone complete installing that? It also depends on network speed. If someone is working parallelly, they can directly. Shows empty. Even if you install also, it shows nothing there. So okay. Okay, I'll try to open my VS Code initially until it gets installed, because we can't keep wasting our time, right? Open the whole folder. So I'll create a folder. I'll create a file, sorry. Let me check for the final time. Is it done? Yeah, it's done. So I can proceed here only. So to open the Jupyter notebook, you need to type a command, Jupyter notebook. It gave you an URL. Oh yeah, it directly out of it. Internet speed is a bit slow. So you can see I created it manually, right? This file new.py I have created it manually, but here opera, right? But here you can directly see over here. Even if I create a new file, new text file, I'll see the changes will get saved over here directly. New.txt. So what does that mean? That means our folder and Jupyter notebook got integrated. So whatever the changes we do here, it will directly get reflected over there and vice versa. Okay. So let's start working on it. So before that, I'll open a file. Yeah, it's already created, right? I'll delete it because we don't use it. So if you want to create a new file over here, you can choose this and name it. Okay, whenever you create a file, it gets directly it redirects to this page. So you can rename it numpy.py. So here it is not py, it is ipynb. So this is the extension. Don't worry, this is also Python, but we run this as kernels. So here this is a cell. So you can add more cells. How many cells you need? So I'll just give I'll go through brief of what this is exactly. So this is a cell. If you want to print something, print hi. So you type something like why it is divided, I'll let you know. So to execute this, you need to press on shift and then click enter. So it got executed. You can see here hi. And what is this? Here we got a number. That means this is first executed. This is the order. And if I write hello and shift enter, so it got executed, but still it shows it is an error because hello is not defined. So if I say uh, a equal to hello, and here even if I don't write print a and I write directly a, okay, if I execute this, it still shows the error because first we need to execute this. Here star shows it is not executed, so that's the reason we're getting an error. So again I'll press on shift and I'll press enter. That's fine. Okay, I need to keep it in quotes, right? Okay, and then it got executed, but no, like it's fine, but here I got number 5. What if I want in an order? I'll also show that. So again shift enter, so it got executed without any errors. Okay, so this shows the interruption of kernel. If you run an infinite while loop and if you want to stop, you can directly click on this. So at present nothing is running, so it doesn't stop anything. So here you have three options. One is code, one is markdown, and one is raw. So what is code? Code is basically this one. So what is markdown? If you have any comments or if you want to specify the topic or anything, you can click on markdown and then write over here. So to write a markdown, you need to enter a hash, and this is a comment. Then shift execute. So this is a comment, that's it. This won't be executed just because this is a comment. So I can again change it, and this is the basic practice. If we leave it here and we again type something and execute it, it gets, sorry, markdown. See, this won't get executed. Even if I run everything, also this doesn't get executed. So what does this mean? I'm going to restart my kernel so that I won't get this random numbers over here. I got it right, 1566. I won't get it. So I'll get it starting from 1 2 3, so in an order. So it looks fine. If you want the same thing, you can also do the same thing. So this is to add a new cell. So this is to cut a cell. This is to copy a cell. If I click on this and if I copy, I can paste it somewhere. If I want to paste it between this, I can click on this. So I got it again. So basically control C, control V kind of action. This is to add a cell, this is to cut a cell, this is to copy, this is to paste, and this is to run a shell. To run a shell, basically you can click on this or you can click on shift enter. You can do both the things. So when I'll run it again. So I think you got familiar with this interface. It's fine. Is it fine?
Yes, sir.
Yes, sir.
Yeah, that's good. So basically we need to get friendly with this interface so that we won't face any kind of difficulties while running any kind of operations or while working with any kind of libraries. So I'll delete all of them. So let's start with NumPy directly. One second. Sorry guys. So for using NumPy, we need to first import it. Import NumPy. And I'll click on Shift Enter. It's fine. Yeah, it got executed well. So I will declare a variable array equal to, as we are using NumPy here, we should call it, like we need to call it NumPy dot array. So this creates an array, but what we are passing here will be giving lists, a set of lists or a single list. 2, 3, 4, 5. So I need to close it, right? Yeah. And then okay. Array. So you see, here it created an array, but we can't keep on writing numpy many times, right? I'll like if you want to name it short, you can use as keyword and make it as you need. But basically, as a basic practice, we give it as NP only, as it is a much better one and short also. So okay, Shift Enter. So what if I run this? Yeah, it got executed. So I'll also run this. That's fine. That should work good. So we have initialized an array. But what are the elements of array? We gave a list. So here a list got converted into an array. What if I need a two-dimensional array? I can still take it. So if I need a two-dimensional array, I need to give another bracket. So now it becomes a two-dimensional array. So I'll again run this. So it became a two-dimensional array. Even if it is not a two-dimensional array, it takes it as we are giving two square brackets. So if I want to print the shape of this array dot shape, so it prints 1 comma 4 because it has uh, a single row and 4 columns, so that's the reason the shape is 1 comma 4. But what if I remove this? It just prints 4 because it is a single dimensional array. It just prints, it just has 4 columns, that's it. Not columns but 4 elements. So when you give it a double square bracket, it gives a two-dimensional array, and similarly for three-dimensional array also. So if you want to check the data type, app dot det, okay, sorry, AR. So all are integers of 64-bit each. So if I don't want them as 64-bit, I can also make them as 32 bits. So I can make them as 32 bits also. How can I make them as 32 bits? Within this, sorry, within this I can give them as np dot int. If I want to make them as 32 bits, I can give as int 32. And if I run them, I'll run all of them. You can see the change. Okay, it still didn't get executed on the way. Okay. Oh, okay. Oh, Okay, let me check. If you have any doubts, you can also check the documentation. It's more simpler rather than remembering everything. You can directly refer the documentations, and if you get more familiar, you can directly use it to the absolute beginners guide, as we are absolute beginners. So here, whatever I used, I took the reference from the documentation, so it gets much easier for us. You can see here they have performed slicing operations, everything, but using NP arrays, not direct arrays. They used NumPy arrays, and they also used the indexing concept, like taking the zeroth index element, printing that, and also the slicing concept as we have discussed in our previous classes. Yeah, there are a lot more to come. That's fine. Okay, remove this one. Let me cut it down. So let this be our array, and we'll start few operations on them. So I'll use I'll use a variable zeros is equal to np dot zeros, 2 comma. What does this do? So here basically I gave 2 comma 5, which are its values, I mean arguments for this function zeros. So this function was previously created by someone who created this numpy. So if I give zeros 2 comma 5, what does this do? It creates a matrix of 2 rows and 5 columns, and everything in the 2 rows and 5 columns, it has zeros. So let me run this also, and then I'll show this zeros. So you can see 2 rows and 5 columns, everything got initialized to zeros initially. So this is a function, and if we'll take it as np array equal to, I'll take few values. I'll make two-dimensional array. Okay, I'll take some random values over here. So what I'll do, okay, it's np.array. P dot range. Bit sort. It sorts my array. So whatever it has in some random order, it sorted it will. Okay, this is common like there also and here also, but the running time, the time taken for that and this is much better than the previous methods. This one is much better. So if I want to print a range of elements, like you have the idea of range, right? If I give from like if I give range of 5, it takes from 0 to 4. So if I want to take a range here, I'll use a variable rng. So np dot arrange. There we have directly used range, but here we'll use arrange. And if I give a range, oh my, yeah, it is a range, okay, and I'll print rng. So it gives me range of 0 to 15 elements starting from 0 and ending till n minus 1, which is 15 minus 1, total 15 elements including 0 and 14. So it has many more functions like this. So let me differentiate between NumPy array and Python list. Sorry, I mean NumPy list and Python list. So I'll cut all of them. Okay, Control Z won't work for this. Import NumPy as np, and I'll take Python list as pylist is equal to 1 2 3 4. So NumPy array I'll take np dot array. So this is a basic syntax. Why I'm repeating many times, because we'll be using this more and more when we'll be dealing with complex applications. So I'll print file list and I'll print np array. Okay. So there is nothing much difference as you can observe, but I wanted to show, if you want to just print a list, you can directly use this. But if you want to convert this list as an array, you should use this. What if I pass this here, file list. Okay. Even if I run this also, nothing will change. So it took this as an argument, like this variable I have called inside this, and it took this as an argument. The difference I wanted to show is NumPy arrays are faster and support vectorized operations, and list can have mixed data types. NumPy arrays are homogeneous. See, if I give this as I, let me test it again. See, the advantage is basically the arrays, the Python arrays doesn't take anything other than the numbers or integers. But here, by using this NumPy arrays, we can also take heterogeneous data types inside an array. We can't directly take the values inside the array as 1 comma 2 comma I comma j comma k. So that's the reason we are using a list. A list we are passing inside the array, and array takes every type of data type. But here we need to observe one thing: we can't perform multiplications between an integer and a string. So that thing we need to make sure, because we can directly use this, and we can directly display them, but while performing operations we need to be careful about them. So we have also seen np zeros, right? Okay, look at this. We have seen np zeros, right? np dot zeros 2 comma 3. specify them even though it has parentheses, because this is an array, right? Matrix, I mean. So here if I want to print everything as ones, np dot ones 2 comma 3. We don't have this feasibility in our traditional Python arrays, but we have this flexibility here. We can directly make all the elements as zeros or all the elements as ones by just using NumPy functions. See. So you have also seen range, right? I'll also show another example. np dot a range of 1 comma 10. Previously I have taken 15 directly, but what if I want to print a range of numbers? If I want to print by one space or two spaces, like it takes 1 3 5, that kind of things, 1 3 5 7 9 up to 10, that's it. So we can play with this as we like. And I want to show few other operations. np dot linspace 1 10 5. What does this do? Let me check. Yeah, it takes evenly spaced values. The difference between 1 and 3.25, and the difference between 3.25 and 5.5, and the difference between this and this, all will be seen. So if we want something like I'm just showing it, there are different kinds of operations, but when we are solving the real-time problems, we might get faced by this type of questions, right? uh, I need an array which should have same difference between the two elements. So if that comes, this needs to be striked in our mind. Like it directly doesn't strike. As we keep on working on examples, we might get familiar with them, and without even learning, we can directly implement them. Like by experience, by practicing more problems, we can directly use them. Even if you have any doubts, you can refer to the documentation of NumPy directly. If you get worried, like there are lot many functions, we'll be discussing only few of them which are essential for our next concepts. We'll be discussing only them. So there are lot many, as you can see. It's a big ocean, like every library is an ocean. So here we use only what all we need. So after the class you can try different kinds depending on your interest. Okay. So let's get back into vectorization, which means matrices. I'll take a single dimensional matrix which is 1 2 3. I'll take small numbers because even if we do addition manually, it gets better. We can also take as NumPy array also, but it's fine. I'm just taking them as direct Python lists only. 4 5 6 and c equal to okay. So what if I add both a and b? What happens? Any guesses? So will I get the sum of both a and b inside the c, or there is another way which has c? Any answers?
Sir, I don't think you would get any output.
Okay, let's check it. Actually, we'll get the entire thing. No. Yeah, we didn't get any output. So what if I want to add 1 and 4, 2 and 5, 3 and 6? What should I do? Actually, we should use the concept of looping. Here only the concept of looping comes. We need to loop through the entire A and entire B and then add it and append the same thing to C. Let's do it. What if I initialize it A? Let me try it now. Work. No, it didn't work still. Okay, I'll use the for loop only. So here we'll also take an empty array and the operations will perform within that. Here we don't have I, right? So this is another way of writing a for loop where you'll have the variable before only. After the performing of for loop, the next step will get performed. Before we used to write the for loop first, right? After writing the for loop, we used to have statements within that. But to minimize the number of lines, we can also write in this form. For I in range length of A. So here as we are taking the length of A and B are same, I'm using this length of A. It doesn't matter because both the lengths are same, right? Even if I take length of B also, it doesn't matter because the length will be 3 only. So after this for loop gets executed, then it goes back to this and it executes everything. Then it prints the same thing into C. So I'll run this. So didn't print anything. I should print C, right? 579. 4 plus 1, 5 plus 2 and 6 plus 3. So it gives 5 comma 7 comma 9. So in this way you can perform addition between two lists. So we might also perform addition between two arrays. Basically we did it in general Python, but the thing get easier when we are working with NumPy. So let's check that also. A NumPy. To just differentiate between the two variables, I'm changing it. np dot array of, I'll pass this the same thing, array of A. Oh, okay, it's array, right? np dot array of B. So here I'll get it. Previously I didn't get it, right? So I'll take here anp plus bnp. Here I'll get it exactly. Okay, here also I'll get np only. cnp. So that's the advantage with this. We need not have these kind of all complex operations. We can directly convert the lists into arrays and perform the addition. See here 579. I haven't used for loop. I directly converted them into arrays and performed the operations. So that's the advantage. So what's the key takeaway is NumPy operations are faster because they use vectorized computations. So everything gets converted into rows and columns or axis like x-axis, y-axis. So things get easier because multiplication also doesn't take much time. Multiplication and addition or anything, because we the time complexity of a single for loop is order of n, but here it got executed in time complexity of order of 1 only. So I'll also discuss the orders, the time complexity and space complexity after completion of the whole course. I think I will have like a day or two, then I'll discuss them definitely. So I think, yeah, after completion of all this, let's work on small codes, like small mini projects on them. Finally I'll explain slicing also. Print I'll slice them out. Okay, 1 is it can be better because 0 1 2 only 2 are good. If I take more, it results in an error. So it should be within the range, right? 7. So it printed the first thing. So what it does I'll just recap the previous class, like the first week. This is 1 and this is 2, but it doesn't consider this as 2, it considers this as 2 minus 1, which means 1, and 1 to 1. What is 1 to 1? 1 only, right? 0, 1, 2. So that's the reason it just printed 7. This is for one dimensional array, but what if we should do that for two dimensional arrays? Let's check it out. For two dimensional arrays, basically they are called matrices, right? Np dot array of two dimensional array, which means we need to use two square brackets, 1 comma 2 comma 3, and we need to separate them. If we need 3 or 4 rows, we need to separate them, 2 comma 3 comma 4. Let me take a 3-dimensional array, that will be good, and 4 comma 5 comma 6. Close it. Then what if I want to perform slicing? It's just basic. We'll use the same variable name and just pass what all we need to have. If I give 0 comma 1, it will give me the first row and second column. I'll explain it again. Okay, I need to give it in square brackets, right? 2. It gave me 2. I'll just print the array for better understanding. Matrix. So the matrix is 1 comma 2 comma 3, 2 comma 3 comma 4, 4 comma 5 comma 6. What I gave 0 comma 1. So basically it doesn't mean the slicing thing. It directly means here, instead of calling it as slicing also, I can call it as accessing the element of 2 comma 1. So I haven't entered the slicing concept. I'll walk through it. Print matrix of, so what does this do? This is 0th row, right? This is the first row and this is the second row. So by giving this, I want to print all the elements of second row. So to do that, I'll give this, that's it. And if I execute, I'll get all the elements of the second row, which is 2 comma 3 comma 5. So if I want to print it in any order, I can still print it. If I want to print it of 2, I can still do it. Okay. Now let's see shaping and reshaping. So we have an array, right? I'll reshape this array or this one directly. Okay. Otherwise I'll create a new array. np dot array. I can also reshape this, but I want to show how can I make a one-dimensional array into three-dimensional array. If I have 9 to 10 elements, how can I make it into a three-dimensional array? I'll just show it. Array of 1 2 3 4 5 6 7 8 9. So here we have the inbuilt function, which is reshape. Reshape is a variable. Reshape is equal to a1 dot reshape, and here we need to give of what rows and what columns, like how many rows it should be and how many columns it should be. I'll give 3 rows and 3 columns. See, now it got reshaped into 3 by 3 matrix. So that will do for now. Let's go to examples. So what if I want to print the scores, like the average of marks or highest marks or lowest marks within the array. Let's check that. So for that, I'll have an array. It's numpy.array, and marks will be in a single dimensional array, right? I'll take it out of 100. I'll take 70, 68, 80, 85, 96, 99, 100, 65, 64. Okay, so what if I want to print the average marks? Like I wanted to show everything in a single program, so that's the reason I have taken the example. If you want to print the average, what should we do? Average marks. So there is a simple operation which is mean. So what does mean? Like in our school, in our maths, what we do for mean? Mean means sum of observations by number of observations, right? Here also there is an function, we can directly use it to find the mean, and we should pass our marks as arguments. So mean is 82.75. The basic mean, what we used to do in our schooling, sum of observations 70 plus 68 plus 80 plus 85 plus 96 plus 99 plus 100 plus 64 by how many total? 1 2 3 4 5 6 7 8 8. But if we want to do it in general Python, how we used to do? We used to loop through the whole thing, or we used to find, or we used to directly give sum of, and then we used to find the length of the whole array, divide the both things, and then get it. So here everything happened in a single line. So that's the reason we use NumPy. Like if you want to do those kind of calculations, and if there are few statistics or few operations, most of them prefer NumPy only. So mostly it's used in data science, machine learning fields, where normal Python takes much time for calculations. Here we have taken only few values, but in real case scenarios there might be thousands of values. So for that it is more efficient way. So in data, mostly it is used data analysis or data uh, manipulation. So what next? I want to print highest marks. Highest marks. So by seeing, we can say the highest marks are 100, right? Out of 100 scale. So what if we want to print np.max? So this is the common function. We used to use max function there, and here also we are using the max function. But this being a NumPy array, we are using np max. That's it. Highest marks 100, and similarly for lowest marks also we'll use min. np.min. And what if I want to print, there is a case here, you should clearly observe. What if I want to print marks greater than 75? Any answers? Should I use if condition, or I can directly use any function of NumPy, or should I only use if function? Like if you do in general Python, how you used to do it? I print marks 75, okay, 74, like how you used to do in normal Python? Any answers?
Sir, if else.
Yeah, in common Python we used to use if else. It is the best approach and smaller approach. But here we don't need to use if else, we have directly a function. For that also we have a function, we can directly call it, we can directly use it. Actually this is a basic thing, like it is not even function, but we specify a condition within our variable. I'll show it. Above 74 marks. So marks of, here we haven't used it anywhere inside our general Python, but here we have the flexibility to use. So if I want to see, here we have a marks variable, right? So I couldn't perform operations directly within that, but here I can directly perform. So whatever the marks in this array greater than 75, I want to print all of them. 70, sorry, 75, 74, right? That's it, direct print. So it is better to write if else also, but when we have the shortcut we can make great use of it, right? So above 74 marks it prints everything, 80, 85, 96, 99, 100. See how simple it is. It's more, it's less complex, right, compared to that. So there are lot many functions depending while seeing this only we understood we can make our computations much easier. But what if we explore all kinds of functions, we might find our mathematical functions more simpler. So that's the reason NumPy is the best thing anyone will use, best library anyone will use. So for smaller calculations to larger calculations in our scientific researches or mathematical calculations, they use NumPy. We can also build our simple calculator. Those all will be given for assignments if you are really interested to do. I am also interested to give few kinds of assignments. So let's work on another thing. Let's make it more interesting. One second. Let's try to implement a real world scenario, like real case scenario. Excuse me. So what if I want to build a movie recommendation system? Not like it doesn't have any front end, but how the back end works. If we want to analyze, we can directly do that. So what we have in a movie recommendation system, we'll have an array of movies, right? We'll define few movies and we'll take ratings of the users and we'll calculate the average ratings for each movies, and what is the highest rated movie, we'll show that. So these are the 4 steps we do, right? So for that we'll take another file, new notebook, and I'll name it as movie. So here if I want to check, you can see here numpy.ipynb. So whatever the files we create in Jupyter Notebook, it gets saved as ipynb. So it looks in the same format, which is also better for us if we want to recheck our files, like how we did that, we can do. So here also I think we can write board numpy as, but I prefer that UI only, like it was good actually. I need to install a few extensions. So let it get installed, we'll stick to this. NumPy as np. So we'll take a variable movie is equal to np dot array of a. Okay, we'll take some real movies. Can anyone suggest me few movies? Few movie names. Anyone please suggest me few movies? I don't hesitate. Like say whatever the movies you have watched. 3 to 4 movies, anything.
Sir, Interstellar.
Okay. So okay. Interstellar. Another one. Another 2 movies are good. They'll be good if you give 2 more movies. So I haven't watched movies till now. I'll take the older movies. Okay. So that will do good. We have 3 movies. That's fine. I'll run this. Okay. Now how many are our users? How many are our subscribers? So I'll take it as number of users. I'll take that input from user only. Enter the number of users giving ratings. So as we are uh, taking all the inputs from users only, I prefer we go back to our NumPy, sorry, what we say, our VS Code only directly. Fine. Sorry. I got habituated that. We also have ratings, right? Ratings equal to, we'll initialize it with our zeros. So basically we don't have any ratings, right? For now we'll take it as zeros. We have seen that previously, right? So if I use the zeros function, it initializes the whole array as zeros only. So what should I give here? Previously I gave nothing, like I gave the size, but here we have our size as movies and num users. So it will be our x-axis, this will be our y-axis. What I mean is uh, this will make our rows, movies will make our rows, and number of users will make our columns. So here in this sorry, in this we have our movies, and here we have our number of users. So I'm taking it. So rows will be users and columns will be movies, here and here. And what should this be? Length of movies, right? Did I close everything? No. 1 2 1 2, okay, close it. So here, okay, see, the problem is I'm clicking on shift and enter, so it is directly getting executed. Remove both of them. For I in range of what range? Should take the range of number of users. So what I'm trying to do, I'm taking the rating of each and every user. Like if I had if we are of 5 people, I want to take rating of each of you, right? I want to take rating of person 1, person 2, person 3, person 4 and person 5. So for that I given a for loop to take input from each user. Print, and here I am using the function, the why I am using this, to use the variable within the statement. Okay, enter your rating 1 to 5. Leave a range 1 to 5 for the following movies I'm taking from each user. So I should also display the movies, right? So for that I loop through the movies. For j in range, length of movies, and also I'm opening a while loop here. While true, until it is true, it should get executed. Rating should be taken from user again. So here I am taking the number of users from user, and like we can also give it static, we can also keep it static also, but for better case I'm taking that from user only directly. So here I'll take the ratings input. Here I want to print all the movies. What all the movies? I want to print all of them. Movies. Movies of J, because here it shows all the movies, right? Like we have used another for loop to loop through all the movies. Input for movies. So rating should be of 1 to 5 only, right? We are comparing the user rating if it is between 1 and 5. So sorry, it should be 1. Why are we doing this? Why should we do this actually? So it checks and stores the rating in NumPy array only if it is between 1 and 5. If not, it discards directly. So we need to use that. It takes it directly and stores it somewhere, right? So for that we are using that. And a break statement. A break statement, as it takes all the 5 inputs, it should break the loop. If the loop, or if the range is above that or below that, we need to print enter valid rating. Okay, so I'll exit from the for loop. I should find the average, right? Average rating is equal to np dot, we saw right previously, mean. It takes the average of ratings, and the axis should be 1. Axis, what should be the axis? It should be 0. So what does that mean? 0 axis means from the y axis. So if the axis is 1, it is the x axis. Best movie, we should show the best movie depending on which has the highest rating. P dot argmax. So I haven't discussed this, but it finds the maximum value. I'll take it as average only. So I should print the results, right? Print average rating for each movie is. So don't worry, I'm just trying to show how we can use this in real world scenarios. Like we have seen this in functions, right? But what if we want to implement this in real time, like in backend? So to show for every movie, I'm looping through all the movies again. For I length of, okay, movies. Movies. Average tab. Average of I. So here I want to round it off to only two floating points. So sorry, I haven't discussed that. I'll show it directly here only. So at last I should print, right? The best rated movie is this one. Print the best rated movie is. So here also I'm using a NumPy function. Movie best movie actually I'm trying to make it bold. Of rating average. Average of best. So it should do, I think it should work well. So what's the error here? Okay, it's movies, right? Okay, So let me run this. Python movies.py. Number of users, I'll take 4. User 1. Interstellar. What's my rating for Interstellar? I'll give it 9. Okay, I should give it within 5, right? I'll give it 5. What's wrong? Int object doesn't support item assignment. Okay. Everything looks good, but I'll make it another variable for now. Ratings. That should work. Four, 4, 5. User 2. Give 5, 4, 4, 3, 4, 2, 5, 5. So here you see the best rated movie is Thor because it has the average rating of 4.5. So it works this way. We can directly manually calculate 5 plus 4 9, 9 plus 4 13, 13 plus 5 20, 20, not 20, Thor, right? Okay, 5 plus 4 9, 9 plus 4 13, 13 plus 5 19, sorry 18, 18, I'm sorry, 18 by 4, which is 4.5, and it calculated every average for all the movies. So within this all movies, Thor is the best movie. So in this way we can also create more and more applications. So this is the basic one. If we use it if we do it using direct Python, it might take longer lines of code, but here it became more easier because mean and argmax made our work much easier, right? So that's that. So we also have more of them, but discussing all of them makes NumPy more complex. We'll next in our next class we'll discuss pandas. If NumPy is clear, we'll directly go to pandas. If NumPy is not clear, we'll discuss few more examples. And after discussing NumPy and pandas, we'll integrate both of them and create few projects, if possible, 2 or 1. So that's for the class. Thank you so much. If you have any doubts or if you want NumPy extension, or if you like, you can suggest me if you want NumPy tomorrow or you want pandas directly. We'll plan accordingly.
Okay, sir.
Okay, is NumPy fine? Like, is it clear? Everything is clear?
Yes, sir, it was clear.
That's fine. Yeah, thank you all. Thank you so much. So let's catch up in the next class with pandas. So bye.
Yes, thank you, sir.
Thank you, Aman. Good night.
Good night, sir.